We introduce an interactive image segmentation and visualization framework to identify, inspect, and edit objects just a few pixels wide in multi-megapixel high dynamic range images. Here we demonstrate the interactive visualization toolkit in an application of cosmic ray detection in astronomical images. We check the GPU availability at startup. You can host the program on a local GPU server, and everyone in the private network can access and enjoy GPU acceleration no matter what devices they use. Now let's load a FIS file. And let's run our deep learning CR detection model. The top right corner shows the overview of the image. You can navigate from here like in other tools. The left-hand side window shows a 16-bit scientific image that is normalized or mapped to 8-bit for visualization. Let's change to linear scaling for a better look of this pair of colliding galaxies. The segmentation mask on the right is always synchronized to the image window. The thumbnails provide shortcuts to jump to detected objects, ranked by their size, so we don't have to look for tiny objects in the vast image. You can navigate with mouse clicks and zoom in or zoom out using the scroll wheel. Let's change back to Z-scale to verify these cosmic ray contaminated pixels. Here we find a suspicious detection. Let's assume the astronomical source nearby is important, so we need an accurate mask here. The pixel location's original value is shown at the bottom left corner for reference. We can manually adjust the range to read from the data for best visualization. It is a true positive detection, but probably missing a few pixels. We can apply morphological operations like dilation to expand the predicted mask from all directions. We can also lower the threshold to see if the model actually detected those pixels. Now it's complete. We're also working on adding the paintbrush tool to allow pixel-level editing. The interactive visualization toolkit is part of our CosmicCon framework. They are open source and available on GitHub.